So the home play for today, it says represent the following 4 different ways. So I'm giving you 8 sets of problems, and I want to represent 4 different ways. Today we're going to learn those 4 different ways, okay? And it's just basic stuff. I just want to make sure that we're approaching these problems with different approaches, from word problems to computation to symbols. And that's how the entire school year is going to go. We're going to be, when we get to equations, solving equations different ways, graphing equations different ways, and so on and so forth. Copy that, and we'll get started with it. All right, here we go. Our objective for today: I can add and subtract real numbers. 3 together. 1, 2, 3. I can add and subtract real numbers. So we started our school year with integers. Now we're going to get into what we call real numbers. So, question: what is the concept for today? Tell your neighbor, please. Okay, I heard a bunch of stuff. Let me repeat the question. What is the concept for today? That is correct. Real numbers. Tell your neighbor where to write real numbers on their Cornell notes. Very good. In the FAIR model. So the FAIR model is here. Real numbers. What are they? Real numbers is the set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Bless you. Real numbers. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Say neighbor the definition for real numbers. See what we're doing there? Yeah? You're good? All right. So, examples. Let's see. 2/3, 7.25, 23, negative 8, pi, and of course, square root of 2. And what we started with this week, we started with all the counting numbers. And if we include 0, they become what? Whole numbers, yes? And if we include now the opposites, what are those? Integers, right? So including all those. So all these are real numbers. Copy that. Because you don't go to bed early. My goodness. Write your utensils down, look up to the screen. So let me just clarify in regards to the definition. It says real numbers. The set of all numbers that can be represented on the number line. Here's my number line. We said that these are all integers, right? Can we also plot in there 2/3? Yes, it's somewhere in between 0 and 1, yes? How about 7.25? Yeah, somewhere over here. 23 over here. Negative 8. Pi is somewhere 3.14 something right here. And square root of 2 is somewhere about right here. So those are real numbers. Now let me elaborate on what is not a real number. Before I go there, though, look at this. Square root of 16. To find the square root, find utensils down, look up to the screen. To find the square root, we need to find 2 factors. What are factors? 2 or more numbers that multiply. But specifically for square roots, 2 factors that are the same number. That's the rule. So think about it. What number times itself gives us 16? Everyone. That is correct. It goes right here. So therefore, square root of 16 is that. But that's not the only number times itself that gives us 16. Talk it over to your neighbor. What other number times itself gives us the product of 16? See if you can find it. Go. Hands if you got it. Yes. Negative 4. Negative 4 times negative 4. What is negative times a negative? Positive 16, right? So negative 4 is right here. So yeah, that means square root of 16 is also a real number. Do you agree with that? All right. Now check this out. Using that same idea, writing utensils, you'll finish copying in a little bit. Look up, please. Square root of negative 16. Tell your neighbor the factors of negative 16. Oh, and by the way, remember the rule to find the square root. It has to be the same number times itself. Find me that number, please. Some of you are like, what are you doing to us, Mr. Q? I know, right? Is there such a thing? No, that means that this is not a real number. So if this is not a real number, think about it. Now, use your noodle. If all these are real and this is not, what can we name this kind of number? If these are real, what can we name that one? Tell your neighbor, what can we name that kind of number? All right. I hear your conversations. I heard fake numbers. However, let me give you a clue as to what we call them in mathematics. Look up over here. Imaginary numbers. That is correct. Some of you are like, imagination. I saw that in SpongeBob. Yes. So write that in here. Square root of negative 16, and these are known as imaginary numbers. You're going to be using these once you get to Algebra 2. And in Algebra 2, they're also going to call them complex numbers. Complex. All right? So with that said, once again, imagine you take a picture of this, and you're going to snap it, Instagram it, or whatever to your friends. Come up with 3 hashtags that you're going to attach to that picture as to what real numbers are. What are real numbers? First one, Jimmy, go. Wow. Wow. Did you ever hear that one? Hashtag real. My goodness. Woo. I see like a drop of sweat coming out. Oh, man, I thought about that one really hard. What other one? Yes. Hashtag non-imaginary. And one more. Yeah. Hashtag number line. However, let's clarify this. Look up, please. Do you think I can make a number line with these kind of numbers? Think about it. Can I keep writing those kind of numbers? Yes. What would I call that number line? Imaginary number line. So therefore, how can we clarify this hashtag? Tell your neighbor, how can we clarify this? Everyone, hashtag real number line. That is correct. So from now on, whenever I'm asking for a definition for real numbers, make sure you write real number line. Because if you just write number line, it could be either imaginary or real. Okay? All right, copy that. Let me move forward. Underneath your prayer model, I'm going to have you write steps for today. So I want you to write steps. I'm going to go fast, so stay focused. And today I'm going to focus on addition. So to add real numbers, step 1, represent each number on the number line with tiles, ground zero, and symbols. So how many different ways do we have? Number line is one. You guys remember the number line? Yeah, Mr. Q, we love those. All right. How about tiles? Have we been using tiles? Have we seen ground zero? Yes. Have we used symbols or numbers? Yes. Step 2, identify all zero pairs and use the absolute values to add. And at the end, we are always going to simplify. Since we are in expressions, we are doing what? Simplifying. Since we are in expressions, we are doing what? Simplifying. Since we are in expressions, what are we doing? Simplifying. All right? We good? All right. All right, copy that. I'll give you some time. All right, so 3 easy steps. Number 1, represent each number on the number line. That's one way. With tile, second way. Ground zero, third way. And with symbols, which is the fourth. We're going to identify 0 pairs and use absolute values. And at the end, we simplify because we're in expressions. Just to recap. Oh, my bad. Ground zero. Do you guys remember when we covered that lesson on Monday where I asked you to, or hopefully to watch the video? Yes? Did I revisit that the following day using the animation, all that? Okay, so we got that. The only one that I think I need to revisit is absolute values. We know how to use number lines, yes? And then I'll show you, refresh your memory on that. So writing utensils down, pay attention to this one. So I'm going to add these using absolute values. Writing utensils, look up to the screen. And this is a review. You should have done this in 7th grade. Here it goes. To add numbers with the same sign, I'm going to start with the absolute value of 3. What is the absolute value of 3? 3. What is the absolute value of 6? 6. Since they are the same sign, I add these two absolute values. 3 plus 6 is 9. What symbol was the original number for these two? Positive. That's why this stays as positive 9. Let me use the absolute value for this one. What is the absolute value of negative 2? 2. Absolute value negative 9. Since they're the same sign, I add these. 9 plus 2 is 11. However, what was the original sign for both of these? Negative. That's why it remains a negative. Is it coming back a little bit? Yes? Now look at this one. Absolute value negative 8 is 8. Absolute value of 12 is 12. However, these signs are opposites, which means now we're going to subtract. I always start with the greatest absolute value. What is 12 minus 8? 4. What was the greatest absolute value? The 12. What was the sign for that 12? That's why this remains a positive 4. Look at this one. Absolute value of 3 is 3. Absolute value of negative 15 is 15. Since they're opposites, subtract. That's 12. But what is the greatest absolute value? 15. What was the sign on that one? Negative. And that's how you use absolute values. You got it? All right. On your paper, copy this. Turn your paper over, actually, in the back. And, of course, ground zero. There it is. Example 1. Copy this one. Add 4 ways. Negative 3 plus 7. Copy that. And we're going to do this one together. All right, so I want you to do, you're going to do 4 partitions, 1 for each way that we're going to represent this. The first way is using tiles, and by now you know how to do that, right? All right, what's my first number here? Negative 3, so I do 1, 2, 3. What's my second number? 7. 1, 2, 3, 4, 5, 6, 7. I do the additive inverse here, and then I have the additive property of addition, and this is what? Positive 4. Everybody clear on that one, yes? All right, here goes ground zero. I'm going to put ground 0. So I'm going to draw my ground 0 right here. What's my first number that they give me? Negative 3. That means it's the whole of negative 3. What's the second number? And that is dirt, right? That goes above the ground. That's positive 7. Question. Does this whole dirt, look up to the screen, does this whole dirt fit in this little hole? No, that means we're only going to probably use this much. Is that correct? So that means this much will fit in here completely. So do we have any more hole? Do we have any more hole once we cover it? No. What do we have left? Dirt. How much? 4 feet. You guys remember that? Yes? All right. Third way. Number line. Draw your number line here. And I'm going to write the problem, which is -3 plus 7. So here we go. Always start at 0. Tell your neighbor what I just said. So here we go. First number, -3. That tells me to go to the left 3 steps starting at 0. So I go 1, 2, 3. I land at -3. Next number tells me to go to the right from where I am at, where I landed, 7 steps. Now I'm going to go to the right from here. 1, 2, 3, 4, 5, 6, 7. And where do I land? 1, 2, 3. I land at 4. And the last way, using the absolute value. -3 plus 7. Here we go. What is the absolute value of -3? 3. What is the absolute value of 7? 7. Are they the same sign? No, so we subtract. 7 minus 3, that's 4. Which is the greatest absolute value? 7. What is the sign, original sign? Positive, so this is +4. Talk it over with your neighbor. Let them know, make sure they understand each of the ways, because I'm going to give you one right now so you can do it by yourself 4 different ways. Talk it over with your neighbor, please. All right? All right. We got this, yes? Piece of cake? All right. Do this one by yourself. Example 2, it says add 4 ways, -4 plus -5. Copy that, and I'll give you some time to do that. Ready, go. All right. So once again, 4 different ways, piece of cake, yes? But when it gets tricky is when you get to these. Look up to the screen. Writing utensils down, look up to the screen. Look up. Really quick, I'm just going to get started with this. This is what? 5 6s and 3 6s. That means I need to make some pies or something and divide them into 6s, right? And this one tells me how many? 5 negatives. And this one tells me how many? That means that this cancels this, this cancels this, this cancels this, and I'm left with -2/5. Same idea, okay? So once again, the hopefully for tonight was 8 problems. I want you to represent them 4 different ways. I hope first week was okay, right? We did okay? All right, have a good one, guys. The video will be uploaded at the end of the day. Enjoy your home play. See you guys till Monday. Bye.